Thank you. Howdy, y'all. Anybody who's watching at home? Take out, please, your worksheet 6D-2. That was on ArcLink. Looking at that for today.
I thought we were sitting there.
And let me come around and check. I have your worksheets out. I'm going to check them off in about whenever I get to your page. I'm going to be relatively merciful as far as completeness, if that makes any sense. But do fill in the answers when we get them.
How did that go yesterday? I know, she said I thought it went pretty well. I got it in 4 times and then I gave it to Wait, so far. You can keep it. No. I just no.
What was the beach? This thing is all mud. It was so gross. From yesterday.
But like 10 days or something like that. Yeah, I know.
Okay.
It's pretty gross.
Attention up here, please. Please grab your favorite red writing utensil. Here we go. The first one was the only one that you needed to give the answers in radicals. And in case it relieves any stress, on the actual test, I cannot hear over the chat. On the actual test, I am not going to have you do an exact answer. I'm just going to have you do decimals. So this, I wanted you to have at least one experience with it. Number one was kind of interesting. I'll show you in a minute. Number one, it is, there are 2 radicals over a number. So the top is 80 radical 10. Write this down if you don't have it. With the red writing utensil that I told you to get out about 45 seconds ago. Anybody missing a red writing utensil? I have a few over there. You might want to grab your own. Thank you. 80 radical 10 minus 13 radical 13 all over 27. Number 2. Oops, hang on a second. Got it. 27. Number 2, 80, 80.5420. Number 3, 2.1325. 2.1325. That was number 3. Number 4, 7.4136. 7.4136. Got it? Next page, number 5, 2.1466. 2.1466. Number 6, 3.8202. Caution, when you do it on a calculator with any trig function, what mode should it be in? Radians. If it's in degree mode, you'll get the wrong answer. Right. 3.8202. Number 7, 1.2780. 1.2780. What should have tipped you off on the radians also is they go from 0 to pi instead of 0 to 180 degrees. And it repeats. All right. I'm going to save 1 for a second. Any questions on 2 through 7?
Could you just repeat 3?
Yeah. Number 3 is 2.1325. Let me do questions first on 2 through 7. Then I'll go back and do 1. Yeah.
Do number 4.
Number 4. Y equals x cubed minus x. And it's from 0 to 2. Here's the setup. I I do need people tuning in and no extraneous noise. Everybody else is not working on this, find something else to work on, please. So y, otherwise known as f of x, is this. Y prime is 3x squared minus 1. Now, I will show you how to type this in with the parentheses where you don't have to simplify it. I think it's a little risky, but if anybody wants to do it, if you're really good at placing parentheses properly, this is a little faster. Watch this. I want to calculate y prime squared. There's two ways to write this. Please do not do 9x to the fourth minus 1. It's square the first, double the product, square the last. You could just write it like that, squared. Or 9x to the fourth minus 6x squared plus 1. Make sense? The arc length is equal to the integral from 0 to 2 of radical 1 plus this thing. Now, it's completely up to you which one you want to write. I actually did this one because it's relatively easy. 9x to the fourth minus 6x squared plus 1, and then a dx at the end. I would encourage you to simplify that a little bit. These parentheses really don't do anything except show off. So it's the integral from 0 to 2 of radical 9x to the fourth minus 6x squared plus 2. That should give you your answer. Yeah, question?
Could we,
Oh,
would it be
go ahead,
okay
Kyle. Keep
if
going.
we, plugged in y prime into y1 and then like plugged in y1 just to like would that work?
Oh, wow.
Just because it was just like a lot
Kind
of
of.
numbers.
The short answer to that is, hold on, let me think for a second, because the calculator can do some goofy things. Maybe. I'll show you a way to do that in about 3 minutes.
Okay.
This thing, type in math 9. So the very first thing is the function. So radical 9x to the fourth, 9x power 4, minus 6x squared plus 2. Close the parentheses for it if you're on the old calculator. By the way, if you're on the new calculator that puts the symbols in for you, be careful. When you need to move to the next thing, you have to use the arrow keys to get out from underneath the radical. Otherwise, you're going to get a bunch of garbage under the radical. Comma x, comma 0, comma 2. And I got 7.413645, which matches the worksheet. So if you want to know the full thing's glory, 7.413645112, and they wanted you to round to the 10,000. Okay. Oh, you did the y1 trick? Yes. If you want to do the y1 trick, the question is, if you go to the y equals screen and you put in 3x squared minus 1, were you planning to square it ahead of time?
No.
Like parentheses squared? Okay. So what you'd have to do, you'd have to do math 9, so FNINT, parentheses, then radical, open parentheses, 1 plus y1 squared, and then comma, whoops, comma x, comma 0, comma 2, and yes, that should work. Don't shoot, take my wallet. Yeah, sorry. Any questions? I'm in a weird mood this morning.
Me too.
By the way, if you can spare any prayers, our kitty is going into the vet. She's getting like 3 teeth pulled out, so she's going to be an unhappy kitty. We only have 1 kitty now. So. Yeah, the other one passed away. She lived almost 20 years old.
Michael has surgery today too.
Yeah, that's true. That's a little more high on the priority list, but if we can cover both, that'd be awesome. My wife is taking her to the vet, and my wife doesn't drive, so it's kind of, she's begging a ride, so it is complicated. But yeah. Next. Any other ones 2 through 7? Otherwise, I'll pick up back to. Going once, those feeling okay, 2 through 7? Think you can do that on a test? Which is most likely what the type you're gonna see. I'm just about to, okay. Everybody 2 through 7, okay? All right, let's try number 1. Now, if you tried this on a calculator, you'd get a decimal, which is now what we want. Is everybody okay with this one? Am I still writing it? Speak now or forever hold your peace. Okay. I now pronounce you mathematician. I'm in a very strange mood. So here we have y equals x to the 3 halves. And they're limiting from 1 to 4. Here's what I would do. Look up here, please. Y prime is 3 halves x to the 1 half. Does that make clear? Now you have to find y prime squared, which is this thing squared. 3 halves, basically 3 halves radical x squared. This will turn into 9/4 x. That'd be okay with that. So here's the arc length. It's the integral from 1 to 4 of radical 1 plus 9/4 x dx. Now, how do you do an integral of this thing? Believe it or not, we've done a problem like this before. U equals 1 plus 9/4 x. This is a substitution problem. Then du is equal to 9/4 dx. So question, is 9/4 dx lying around anywhere? Not exactly. Dx is, if you can get rid of the 9/4, multiply both sides by 4/9. Cancel, 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 cancel. So 4/9 du is equal to dx. Now we've got it. It looks like this. It's the integral radical u times 4/9 du. There's just one catch. This 1 and 4, what letters are they? They're values of what? They are A and B, but what variable are they running through? They're values of x. X goes from 1 to 4. You cannot put 1 to 4 down here. Look up here, everybody. You cannot go from 1 to 4 here. I'm not doing x's anymore, I'm doing u's. So let's find out. If x is equal to 1, what's u? It's 1 plus 9/4 times 1. So it'd be 13/4. Does that make sense? This is 4/4 and 9/4, 13/4. In other words, I have to switch the boundaries from x's to u's. So u is going to go from 13/4 to something else, I don't know yet. If x is equal to 4, let's see what it is. So u is equal to 1 plus 9/4 times 4. That's actually kind of nice. The 4's cancel, and it makes u equals 10. Everybody still with me? Let's try this. Pulling the 4/9 out in front, looks like this. 4/9 times the integral from 13/4 to 10 of, I need to switch this to derivative-friendly form, u to the 1/2 du. And that we can do. It's a pain in the neck to get there, I'll be the first one to admit that. But what's the antiderivative of u to the 1/2? It's 4/9 in front. And it's going from 13/4 to 10. But what's in here? Do the antiderivative, somebody. B.
10 to the 1/2 minus.
Just don't worry about the 10. Don't do that. Just do this. U to the 1/2 antiderivative.
That would be
What's the new power?
3 over 2.
3 over 2. And then what?
Then don't you divide it by 3 over 2?
Divide by 3 over 2. How do you divide by a fraction?
You multiply by the reciprocal.
Right. So it's 2/3 u to the 3 halves. Everybody still with me? Multiply these. You should, I'm gonna pull the 2/3 out in front. This is gonna be 8 over 27. And then u to the 3 halves. Can somebody tell me what that is? Where's u to the 3 halves? There's a radical version of that. How many whole u's? I remember? Yeah, 1. How many are left over?
Radical U.
Yeah, u times u to the 1/2 is u radical u. That's this. From 13/4 to 10. Which one do you plug in first? The 10. So over here, let me squeeze it in. So it is still 8 over 27 in front. And then it's going to be 10 radical 10 minus, this is going to look ugly, 13/4 radical 13/4. That's your answer. You just need to simplify it. This thing does not simplify. This does. There's one little thing you need to do. Anybody see it? There's something wrong with leaving it like that.
Like the radical 13, radical 4.
Yeah, do these separately. So what is this really? It's radical 13 over 2. So let's multiply. 8 over 27 times 10 radical 10 minus, this is going to be 13 radical 13 over 8. Now distribute. You're going to get 80 over 27 radical 10. Yeah, plus negative. The 8's cancel in this one. Negative 13 radical 13. Okay? And this does not reduce. I think they pulled the 1 over 27 out in front, which you can. It's the exact same answer as the one I read off, if you distribute it. If you took the 1 over 27, or take the 27 and divide it up, it'll look like that. Does that make sense? It looks ugly, but that's an exact answer, which is far more valuable than a decimal approximation usually. Questions? Okay, again, there are 4 steps in here. First, get it in, do the actual arc length formula. 2, recognize this is a substitution problem. If you do u, du is sort of kind of in there. You just had to get dx by itself. Then actually do the antiderivative and then simplify. And do that. Questions? Okay. There are 2 more topics in this chapter, and then we are looking at the chapter 10. So take out your notes, please. New section, which is going to be strongly related to this in 2 ways. First, the arc length formula is going to show up again. Second, you will not need to give me an exact answer for the vast majority of problems. It'll usually be a decimal. Everybody okay with writing this? Anybody still writing? Speak, going once, twice. Anybody still needs? Polly, you still writing? Okay, okay. Everybody good? Let me draw a shape for you. We have covered 3 types of things in this chapter. Everybody look up here, so I know you're paying attention. We've covered area between 2 curves. How do you do that, Jack?
Area between 2 curves. It's like disk.
That's if you rotate them. That's volume. If I just flat curve, how do you get the area between them? Like, for example, if I just said, here's an upside down parabola, here's a right side up parabola, What's the area between here? How do you do that?
Oh, is that like, you subtract antiderivatives or something like that, I forgot what it's called.
Right. In other words, if I'm just going from A to B, you take the integral of the higher one, which would kind of look like this, then subtract the lower one, and you'll get the leftover stuff. So in other words, the higher integral minus the lower integral, ta-da. That was the first thing we did this chapter. Second thing we did this chapter was rotational solid volumes. We could do it by disks, we can do it by shells. What's the volume for a disk, Julie Sushant?
Equals pi r squared h.
Pi r squared h, good. What is the volume of a shell, Max?
2 pi RHT.
Correct, 2 pi rht. That was the second thing we did. The third thing we did so far this chapter is arc length. Can somebody recite, without peeking, the formula for arc length? John?
It's the integral
Mhm.
from A to B
Yep.
of radical 1 plus f prime squared dx.
Correct, f prime squared dx. That is arc length. Memorize that. The fourth thing we're covering today, quick example. Suppose you have a little stem of y is radical x, and I'm just going to go from 0 to 4. I've been doing that one a lot. Stay with me, don't get distracted. I'm not looking for the area underneath, just that curved, pretend this is made out of a curved piece of wire. And now, I'm going to spin it around the x-axis. This is going to cause a hollow bullet. Does that make sense? So it's hollow inside. And what I'm going to ask you for is the surface area. Like if you had to paint this thing, how many square feet of paint would you need? And this is not a standard geometry shape. There are formulas for almost every geometry shape that has straight edges. A cone, there's a formula for surface area. Cylinders, surface area. You can find surface area for any, like a 6-sided shape, 8-sided shape, 20-sided shape, 100-sided shape. As long as they're all regular, you can find the surface area. But anytime you start doing curves, unless it's a circle, we're kind of out of luck. Like even if it's an ellipse, if it's some sort of an ellipse that's hollow, geometry has no idea how to get the surface area. Calculus does. Here's what you do. Do you see that this is going to make a hollow shell? Let me give you the formula for surface area. It's the integral from A to B, 2 pi r. Remember recognize that, by the way? What's 2 pi r? Which looks familiar. It's from geometry. What's the formula for what?
Diameter or circumference, one of the two.
You tell me which.
I'm pretty sure
What's that?
I don't know.
Diameter is 2 times radius.
Yeah.
So this is what?
Circumference.
This is circumference. Yeah, please dust up on those. The circumference of a circle is 2 pi r. The area of a circle is pi r squared. By the way, does anybody remember the relationship between those two as far as calculus goes? What is it? Go.
Derivatives of each other. So
Yeah.
circumference.
The circumference is the derivative of the area. Correct. So 2 pi r, that's circumference. Watch what happens next. Anybody recognize that? You should. We were doing it 5 minutes ago. What is this thing? Math. Arc length. It's circumference times arc length. Take the integral. That's how you get surface area. That's all you do. I would say just memorize these. The way to do that, it's a little more complicated explaining why, but I think I showed you this before. In order to get an approximation, you could just do straight across, which would kind of waste space. It would be smaller than you need. If you just did a cone and got the surface area, you could, and the geometry knows how to do that, but it's too small. If you tried a cylinder, that's easy to calculate, but it's too big. What they did was take arc length, arc length, arc length, arc length, and add up all the arc length and then spin them. This is the spin, and this is the arc length. It's kind of like the arc length all the way around the circle, and all the way around the circle is called circumference. Does that kind of make sense? So if you take the arc length and just circumference it around, you'll get the surface area of pretty much any shape. You just change the shape to whatever you want. It can be like wibble, wibble, wobble, wobble, and you'd have this wibbly, wobbly, wobbly, wobbly surface area. Let's try it. Actually, let me just do the worksheet so you know what's coming. There we go. These, no problem. None of these will require an exact answer. These will be all calculated. Yes. You will. Yes. Yeah. Did I miss anybody? Did I just give? Will, did I give you one of these or no? I wasn't supposed to. But.
I don't think so.
Okay, good. I mean, you can have one if you want. But let's try one. Try number 2. I think about half the class even acknowledged what I just said. Look at number 2 on the sheet. We're going to do that together. Y equals x squared, x going from 1 to 9. That's, so going from 1 to 9, be careful. That's going to go a long, long way. It looks like this. I'm going to kind of zoom out. Y equals x squared. Peace, take over. How far out are we going to go for x? To 9. How far up is it going to be? It's a parabola.
81.
81. It's going to be very, very long. Okay? And we're not going from the entire thing, we're going from here. Like here's the entire right-hand side of the parabola, and we're only taking this part. And then we're going to rotate that around the y-axis. So it's going to look like this. Gentlemen, I really have no problem hearing you. I'd rather not. And then the bottom is going to be this. It's sort of like a rounded funnel with an opening in the bottom. I want the surface area of that. Tell me how to get it. All the stuff you need is on the board. Talk me through it. Here is the main focus.
Well, really the only thing that we have to solve for to put in there is the derivative and get what r is, right?
Let's find out. And by the way, f prime and y are the exact, or y prime are the same thing. What is y prime?
2x.
2x. So what's y prime squared? Careful. Anyway, 4x squared, good. A lot of people put 2x squared by mistake. Make sure you square the entire thing. And we're going from 1 to 9, so can somebody set me up for this thing? There is one extra thing we'll need to calculate, but it's not too hard. Start with an integral. From what to what? Polly, take over.
From 1 to 9.
Yeah, from 1 to 9.
2.
2 pi. Now r, what are we going to put for r? It's kind of like the previous rotation problems. What letter? X, y, dx, or dy?
Be X.
Just look at the direction it's going. It's x. If it were going this way, it'd be y. It's exactly like we were doing with the other rotations. So 2 pi times x times radical what? Max, take over.
So 1
Uh-huh.
plus 2x squared. Oh, well, that was 4x
4x squared, correct.
3x.
That is largely all you have to do. Now, since this is probably not going to get a nice answer, you know, remember how we used to hold the pi out until the end, and in the hopes that the thing would convert to fraction, and you could just slap the pi back on to get an exact answer? There's very little hope of that happening anyway. So it really doesn't matter if you throw the pi in with the integral or not. It's up to you. I'm just going to do it. So go ahead and try this. So it's going to be math 9, so f(n)(i)(t), 2, use the pi key, pi x, then immediately radical 1 plus 4x squared. Close the parentheses for the radical, comma, if you're on the old calculator. X, gentlemen, please don't chit chat, comma, 1, comma 9. Make sure it's not 0 to 9. What do you get? It's relatively big.
3061.9221.
3061.922117, which we're going to round to 9221. That is correct. And you're done. Does that make sense? That is arc length. Now you can rotate it around the other axis. What difference does that make? Like if hypothetically it were rotating this way, what difference would that make? It would actually only change one thing.
You just changed it from X to Y.
Yeah, the radius is no longer x. The radius would be y. Now you'd have to substitute x squared in order to not to have different letters in the problem. But otherwise, it's almost the exact same thing. Does that make sense? Everything they can do that. The rest of the hour is yours. Welcome to pound away at those. Uh-huh.
When is this due?
Tomorrow.
Okay, do you want me to just take a picture and then email it to you?
Sure, that'll work.
Okay.
That'd be fine. Any other questions?
Mr. Gardner,
Uh-huh.
x to the 1/2 squared is x to the 1/4, right?
X to the 1/2 squared is x to the 1.
Oh my gosh.
X to the, x to the 1/2 to the 1/2 would be x to the 1/4. Very good. Are you okay? All right. For those of you watching at home, I hope it's warm down there, Julia. We'll talk to you later. Bye-bye.